Hey guys, today we're going to graph some more sine and cosine functions, but this time it's going to include some transformations, horizontal and vertical. But first, let's review transformations. So first thing we look for in transformations is if something happens inside of the function. Here's the function, x cubed. Here, there's a 2 happening inside of it. That means it is horizontal. And since it is multiplied, it is a dilation. So the first thing that happens here is a horizontal dilation by 1/2. Then outside the function, there's a plus 3, so this will shift up 3. Here again, there's something inside the function. We're adding 11, so that's a horizontal translation. And it's going to go opposite the sign, so this will move left 11. And then outside the function, it's going to move down 7. Inside is opposite the sign, outside is following the sign. And there's 2 things inside of this function. First, we do the dilation. There's a horizontal dilation by the reciprocal. So it's by 1/4. Then it goes opposite this sign, it goes right. But it doesn't go right 2, it goes right 2/4, which is 1/2. So it goes 1/2 of a unit to the right. Then outside there's a dilation. So there's a vertical dilation by 5, so it gets 5 times taller, and then it shifts up 3. So we're going to use those transformations as we continue to graph sine and cosine waves. So a little review of some terms. The sinusoidal axis is the horizontal center line. Okay, so the horizontal center line for this particular sine or cosine wave, this right here is the sinusoidal axis, so we'll call that our center line or the sinusoidal axis. The amplitude is the maximum distance above or below the axis or the center line. So here's an example of the amplitude. A cycle is tracing along the curve until it repeats. So if I start here, I can trace down and back up, and if I go any farther, it's going to repeat. So that is one cycle. A period is the horizontal distance of one cycle. So from here to here is a period. And something new, a phase displacement or a phase shift, that is the horizontal shift, or the horizontal translation, how much it moves left or right. So I could have a displacement right here. If I use this as my displacement, that would be 10 degrees. Then my graph would be starting at the top and going down. That would be a positive cosine equation. If I was to use this right here as my displacement, it would be starting on the center line and going up. That would be a positive sine equation. I could use my displacement right here. That would be starting at the bottom and going up. That would be a negative cosine. So if I use that as my displacement, I would be doing a negative cosine equation. I could also do right here, and then it would start at the middle and go down. That would be a negative sine equation. So a displacement is anytime I know exactly what the degree is or the radian. So here it's 3 when it's on a middle. Here it's 10 at the maximum. Here it's -4 at the minimum. Here it's 11 at the middle. Anytime I know exactly how many degrees or how many radians it is, when it's either on the axis or at a maximum or minimum, I can use that as my displacement. So a general equation, either with sine or cosine, S plus A sine or cosine B theta minus D. So S is the sinusoidal axis. Okay, and that represents the vertical shift. A is the amplitude, which represents the vertical dilation. D is the displacement or the phase shift. And that represents the horizontal shift. And B is 2 pi over the period. It's also good to know that the period is 2 pi over B. And that will be the horizontal dilation. All right, so we are going to find sinusoidal axis, the displacement, the amplitude, the period, and we are going to sketch a graph. Okay, so the sinusoidal axis comes from right here. That is our S. Our sinusoidal axis is 3. The displacement, there is nothing in here, in that spot. So there is no displacement, so the displacement is 0. The amplitude right here is 2. And we also need to know the period. We can get that from B. B is right after the word sine or cosine. B is 1, which means the period is 2 pi over 1, or 2 pi. So when we sketch this graph, the sinusoidal axis is going to be at 3. So there's my sinusoidal axis. It is at 3. The amplitude is at 2, or the amplitude is 2, which means the maximum is 2 above that 3. So the maximum is 5. The minimum is 2 below. So the minimum is 1, which means that my x-axis, or in this case we're using a theta, so my theta axis will be 1 unit below that 1. And I'll put my y-axis right here. This is a cosine graph, which means it's going to start either at the top or the bottom, on the maximum or minimum. And since it is a positive cosine, it's going to start at the maximum. From there, I can just graph a couple cycles and then put in a couple of radian values down here on the theta axis. Remember, when it comes from the top or bottom, it's curving. We don't want to come straight out of there. It should be curving from there. So there's one cycle. There's another cycle. Okay, so it has completed a cycle when it gets right here. So I'm going to put a mark on my theta axis. And then when it's completed another cycle, it's right here. The period is 2 pi. We started here at 0. It goes 2 pi units horizontally before it begins to repeat. Then it goes another 2 pi units before it starts to repeat. So that's going to be 4 pi. Okay, so again, we need sinusoidal axis, displacement, amplitude. We're going to find B so that we can find the period. Okay, so the sinusoidal axis, there's a -3 here. And notice it's not in parentheses, so that's not a displacement. Since it's not in parentheses, it is outside of the function, so that is my sinusoidal axis. It could also be in the front. It would be -3 plus 5 sine theta. So just because it's in the back, that doesn't mean it's not the displacement. That doesn't mean it is the displacement. This would make it the displacement. Without those parentheses, that is the sinusoidal axis. So the displacement, there is none. The amplitude is 5. And once again, between sine and theta is a 1. So B is 1. So period is 2 pi over 1. So the period, once again, is 2 pi. Okay, so we'll draw in our sinusoidal axis. This time it is at -3. Our amplitude is 5. So we'll draw in a maximum. And we'll draw in a minimum. The amplitude is 5. -3 plus 5 is 2. -3 minus 5 is -8. So there's my maximum and minimum. 0 is between -3 and 2. So I'll put my theta axis right in here, a little closer to 2 than -3. I went a little too far with that one because I need to put in a theta. So this time we are drawing a sine wave. So I'm going to start right there on the center line, on the sinusoidal axis. And it is positive sine, which means we're going to go up first. So we go up and down and back, and that's one cycle. Now, coming out of the center, it is kind of straight, not curvy like at the top. Up and down and back. And we've completed 2 cycles. So after completing one cycle, we're right here. After completing another cycle, we're here. The period is 2 pi, so it goes from 0 to 2 pi after one cycle. Another 2 pi, which puts us at 4 pi. All right, once again, we need the sinusoidal axis, the amplitude, the displacement, and B, so we can find the period. The sinusoidal axis here is 6. The amplitude is 10 times cosine. The amplitude is 10. Displacement, it's got a minus pi here, and that minus is inside the parentheses, so it's going to go right pi units. So the displacement is pi. B, there's nothing here after cosine. B is 1, which means the period, once again, is 2 pi over 1, or 2 pi. So So here's my sinusoidal axis at 6. Here's a maximum and a minimum. The amplitude is 10. 6 plus 10 is 16. 6 minus 10 is -4, which means 0 is somewhere in this range, a little closer to -4 than it is to 6. So there's my theta axis. And there's my y-axis. It is positive cosine, which means we're going to start on the maximum. But we're not going to start right here on the y-axis because we have a displacement of pi units. I have to start pi units to the right. So I'll start right there. And down and back is one cycle, and down and back is a second cycle, and 2 cycles is enough to graph. The period is 2 pi, so I'm starting at pi and going 2 pi units, and that puts us at 3 pi. And another 2 pi units later is 5 pi. All right, here our sinusoidal axis is 3. Our amplitude is 7. Our displacement, that tells me we go left. But it's not pi, it's pi over that 2. It's a horizontal translation. When we have a horizontal translation and a horizontal dilation, we have to divide. We're going left pi over 2, so displacement is negative pi over 2. B is 2. So the period is 2 pi over 2. The period is pi. So here's our center line, our sinusoidal axis. That is 3. Here's a maximum and a minimum. Our amplitude is 7. 3 plus 7 is 10. 3 minus 7 is -4. That puts 0 in between these, a little closer to 3 than it is to -4. Since I'm translating left, that means I need to take my y-axis and slide it a little bit over to the right. Because when I start this graph, I have to be over here at negative pi over 2. And it is cosine, and it's positive cosine, which means I'm going to start at the top, pi over 2 units to the left. So I'm starting right there. The period is pi, which means that I need to be repeating pi units after this. Negative 1/2 pi plus pi is positive 1/2 pi. So when I get back to the top, I'm going to be at 1/2 pi. And then, so there's one cycle, and then one more cycle puts me right there. So negative 1/2 pi plus pi is positive 1/2 pi, pi over 2. Plus another pi, here I'm at 1 pi over 2, plus another whole pi, that puts me at 1.5 pi over 2, or 3 pi over 2.